Welcome to our fluid mechanics lecture, and in this video we will answer the 4 sample problems under the topic Principles of Hydrostatics. Now for the first example, we have here the question: what is the pressure head of 800 kilopascal in letter A, water, letter B, mercury, and letter C, fluid with relative density of 0.85. So we're looking for the pressure head. So what do we mean by the pressure head? That is the pressure with the height at the given pressure. So the formula that we're going to use here is H for the pressure head is equal to the pressure all over the unit weight of the liquid. So the letter A, we are given here, the liquid here is water. So for water, we have the pressure head H is equal to given pressure 800 kilopascal divided by the unit weight of water, and that is in 9.81 kilonewton per cubic meter. Now let's put here kilonewton per meter squared for the kilopascal. If you notice, we will cancel out here the kilonewton and the meter squared, and what's we're left here is 1 meter. Therefore, the unit here is consistent. We're looking for H in meters. So what is 800 divided by 9.81? That is equal to 81.55 meters. So that's the pressure head. For letter B, pressure head for mercury, so we have here H is equal to 800 kilonewton per cubic per square meter, and the unit weight for mercury. So what's the unit weight for mercury? If you're not sure, remember the formula: unit weight is equal to rho G. Okay. Okay, so for here, our rho here is for the mercury. Now we're going to use here rho for mercury with the specific gravity. Okay, so for rho of mercury, Hg, that will equal to the specific gravity of Hg and the density of the standard, and that is the water, and then the acceleration of gravity. Okay, and where do we get this part here? So remember that our formula for a specific gravity is equal to the density of the liquid divided by the standard density, and we're going to use their standard density of water. Therefore, our unit weight for mercury is equal to the specific gravity 13.6 multiplied with the unit weight of water, and that is unit weight density of water, that is 1000 kilogram per meter cubic meter, and then we have here the acceleration of gravity 9.81 meter per second squared. Okay, so what will happen here? Again, we have the cancellation. Now in order for us to get the newton, we need the kilogram meter per second squared, right? So we will now have their newton. Now take note, we've used here at the top kilonewton. So if it's in kilonewton, we need to remove their kilo and put here 1000. So 1000 newton per meter squared. Okay, so now we have here 800,000 divided by 13.6 specific gravity times 1000 times 9.81. So 5.996. So you have here 5.996 meters. So that's the pressure head for mercury. Next, letter C. What is the pressure head of 800 kilopascal in fluid with relative density of 0.85? What do you mean by relative density? That is also the specific gravity. So we just have to replace this part here into 0.85. So H now is equal to 800,000 Newton. So remember that it became Newton, so this one is cancelled out. So Newton per meter squared for the pascal, and then the specific gravity 0.85, 1000 kilogram cubic meter, then 9.81 meter per second squared, and that is equal to, so 800,000 divided by 0.85 times 1000 times 9.81. So that is 95.94 meters. So that's the pressure head in this fluid. That's for example number 1. Let's go to the example number 2. In the figure below, given this figure, there are two pipes containing the same liquid of density 880 kilogram per cubic meter. So this is the cross section of the pipe, and they contain the same liquid, the same type of liquid. They are connected using a U-tube manometer. So this is our tube, and they are connected with it. What is the pressure between the two pipes if the manometer contains mercury? So this is the mercury part. So it contains mercury. How do we determine the pressure between the two pipes? Okay, let's assign here, so while solving, let's assign here that when we move downward, okay, let's assign the value or the sign here as positive, and if we move upward, let's assign the unit, the sign here is negative. Okay, so downward positive, upward negative, and I'm going to move here from point A up to point B. Okay, so I will put here first the pressure at A, because I started at point A, and then I'm going to move downward. I'm going to move downward from this point A here up to the surface, the lower surface of the manometric fluid, and that is 1.5 meter from point A down to the surface of the manometric fluid, or that is the mercury. So that is equal to, so plus, if we're dealing with pressure, what formula are we going to use? We are going to use rho g h, because the given here is density. Okay, let's move this now. Rho of the liquid here is 880 kilogram per cubic meter. Then we have here the, so kilogram per cubic meter, and then multiplied with the acceleration of gravity 9.81 meter per second squared, multiplied with the height from point A to the surface of the mercury, and that is 1.5 meter. Now cancellation, or this is kilogram meter per second squared, is actually in Newton, and then we have here meter here. We'll cancel that out, and what's left here is meter squared. So what we got? Newton per meter squared, and that is in Pascal. Okay, that is in Pascal. Remember that. So we're going to We were able to move from point A to this surface. What's next? From this surface up to this part here, we'll cancel that out. Okay, we will not include that in the calculation because they are of the same impact and the same pressure, because they are the same liquid with the same level here. Therefore, we just have to ignore that part. Okay, so from this portion here, from this part, we're going to go upward up to the surface of the mercury. So upward up to the surface of the mercury, and that is negative sign. So that is minus, so minus 13.6. Take note, we're dealing with the density of mercury. So for density of mercury, we have 13.6 multiplied with the standard, the water. Okay, so the density of the water here is 1,000 kilogram per cubic meter, and the acceleration of gravity, so it's should put it here, and the acceleration of gravity 9.81 meter per second squared, and then the height, that is 0.6 meters. Again, the unit here is Pascal. Okay, are we done yet? No, it's not yet done, because we're going to move from the surface of the mercury up to point B. So we're going to have this movement from the surface of the mercury upward up to point B. Now, upward up to point B, that is 0.8 minus 0.6, and that is equal to, so distance here is 0.2. So since we moved upward, that is negative. And then what is the density here? Given the density 880 kilogram per cubic meter multiplied with this acceleration of gravity 9.81 meter per second squared, and the height 0.2 meter. And then we have there equal to pressure at B. Okay, therefore what is PA minus PB? The difference, pressure A minus pressure at B. Okay, so what is the answer here? So the answer here is 68,826. So 826.96. So 68,826.96, that is in Newton meter squared, or that is 68.83 kilopascal. So that's for example number 2. Next, we have here example number 3. The U-tube shown is 10 millimeter in diameter and contains mercury. So the liquid here is mercury. So HD. If 12 ml of water is poured into the left side or left hand leg, what are the ultimate heights in the two legs in millimeters? So it's looking for the final height. So what will happen here is that there is water being introduced into this tube. So if you pour in water, so let's pour in water there. Let's pour the water here. So what will happen here at the left side? So it says there at the left hand leg, if we pour water here, what will happen to this liquid, the mercury? So it will be pushed to the right side. So this is your mercury now. Should we use the same color? this is your mercury. Oh, you could just highlight it. Okay, let's say it ended there. Okay. So the question here is, what is the final height? So this one here is unknown. What's the height here? And also this one here is unknown as well. The height here. Oops. So let's assign that as X and Y. Don't know yet. How about here, the right side? So that is X and Y, and this is one here. How about that? That's probably equal to, so this is if you add them, if you add this left and right, that is 240, right? So that is 240. So let's have here 240, and if increases, it increases here at the left side, at the right side, and then it is being reduced at the left side. So this is 240 minus Y, right? So that is 240 minus Y. So, right? So were you able to understand that point? Because if we add here the left side and the right side, you have there 120. Now if the right side moves upward and then the left side is being reduced there, therefore that is 240 here, the total 240, and you just subtract here the Y in order to get the value here at the right side. Okay, now we need to find what is the value of X plus Y and 240 minus Y. Now let's solve here first what is the value of X. Remember that we were given the diameter of the tube 10 mm and the volume of water being poured is 12 ml. Now we need to convert first the volume ml into cubic millimeters. So how do we do that? Okay, now we have here given the volume 12 ml. Let's convert that into 1000 into ml. Okay, liter, should I say liter? Okay. Why? Because we have here 1 cubic meter. Okay, let's put here 1 cubic meter is equivalent to 1000 liters. So let's use that conversion. Okay, so we have here 1 liter all over 1000 ml, and then let's convert that into 1 cubic meter is 1000 liter. And then since it's going to be mm, let's convert meter into mm. That is 1000 mm in every 1 meter. And let's okay, let's cube that. Therefore cancel out here ml, cancel out liter, cancel out cubic meter. What's left here is what is 12 times 1000 cubed divided by 1000 squared. So that is 12,000 cubic millimeters. Okay, so having known the volume for cylinder, so we have here volume of the cylinder is pi d squared all over 4 times the height x. So that's the height here, x. Given the volume as 12,000 mm cubic meter, that is equal to pi, and then the diameter 10 mm squared all over 4, and then we have here x. We now have the value of x is equal to, so that is 152.79 mm. Okay, so we now have the value for x. Now next, we need to find the value for y. Now looking at this portion here at the right side, for it to be stable, we have pressure at the left side is equal to pressure at the right side, so that the liquid in the left side and the right side will remain stable. So we have pressure left equal to pressure right. The formula there for pressure is gamma H. Same, gamma H. So what's the gamma H for the pressure left? So we have here gamma of water. So this is water, H2O. And then this one here is mercury. So gamma for water is 9.81 times the height is x, plus the gamma of mercury, so 13.6 times 9.81, and then we have here y. So again, where did we get that 13.6, 9.81? It's from the formula. So we need to be reminded again of the formula for the specific gravity equals gamma of the liquid and then gamma standard. So this, we're dealing with mercury. Therefore, gamma of mercury, so this one here is mercury, is equal to Sg. So Sg of mercury equals the gamma of water. So Hg of mercury is 13.6, and then the gamma for water is 9.81. Okay. Next, we go to the right side. The pressure at the right. So that is, we're dealing with the mercury again. So that is 13.6 times the standard gamma for water, and then the height. The height here is 240 minus y. Now we are going to substitute here the value of x. We were able to get the value for x here as 152.79. Therefore, y is equal to 114.38 mm. Okay, just have to convert it into mm. So we now have here, so how do we get that? Okay, let's show that. 9.81 times, we have here 152.79, so 0.15279, is that correct? Okay, plus 13.6 times 9.81. Then we have here alpha x, then alpha equals 13.6, 9.81, 240, alpha x, oh, it's 240 minus alpha x, shit, so, oh, it's 119.99. 119.99. 13.6. So 119. It should be 119. Oh, wait. No. Alpha x So 0.15279 9.81 plus 13.6 9.81 x 13.6 y. Because of the 240. Okay, so remember that the 240 here is in mm. So how about if we put here as, okay, so 0.158, then the 240 here is 0.240. Ship solve. There you go, 100.114. So we have here. So multiplied with 1,000. So oops, what happened there? Or that is 114.38 mm. Okay, therefore we now have here at the left side x plus y equals 152.79 plus 114.38 is equal to 267.17 mm. For the right side, we have 240 minus y. So 240 minus 114.38, and that is 125.62 mm. Okay. So, wait, how about if anyway, you can check that in your calculator. So that's example number 3. Now let's go to the final example. We have here the tube shown in figure is filled with oil. So it contains oil. Determine the pressure head at A and B in meters of water. So in meters of water, what do you mean by in meters of water? Remember the example number 1. So it says there will be different pressure head. It depends on what liquid we are talking about. So the pressure head of 800 kilopascal in water is different with the pressure head in kilopascal in 800 kilopascal in mercury. So the difference here is the denominator here in the unit weight. If we're talking about pressure head in water, therefore your denominator should be the unit weight of water. If we're talking about pressure head in mercury, therefore you're going to use the unit weight for mercury. Okay? So that's how it is in example number 4. That's why it mentions in meters of water, because we're going to use the unit weight of water. So here we're going to use the formula H is equal to the pressure over the gamma of water. Now if it says there, it mentions there in meters of mercury, therefore H is equal to pressure over unit weight of mercury. So that's the difference. Okay, so I need you to notice that as well. Take note of that. So for pressure A, so in order to find the value of H, we need to find the value of pressure. What's pressure at A? So if you look here, this is point A at the top. It's similar with having that point A here at this position here. So from the free surface, so this is the free surface, this is the closed surface. So from the free surface, what is the pressure at A? So again, our movement here is from the free surface up to the point A. So what is the distance there? From the free surface to point A, you have here the distance 2.2 plus 0.6. So we're going to focus on this distance 2.8 meters. So pressure at A now is, we're going to use the specific gravity. So the specific gravity here is 0.85. So again, the formula that we're using here is rho g h. So 0.85. Then the rho standard of water is 1,000 kilogram per cubic meter. Acceleration of gravity 9.81 meter per second squared, and then the height here is 2.8 meter. So what is the pressure at A now? So 0.85 times 1,000 times 9.81 times 2.8. So that is 2347.8. So that is 2347.8. And what unit is that? So what unit is that? Kilogram meter per second squared. That is Newton. Cancel here meter squared. So we have the unit here, Pascal. So H now is equal to the pressure to 23. That is 23.35 kilopascal divided by the unit weight of water, and that is 9.81 kilonewton per cubic meter. So that's actually kilonewton meter squared. So H is equal to 2.38 meters. How about pressure at B? How do we determine pressure at B? Where's point B? Point B is inside. Here. It's enclosed. So from the free surface, so this is our free surface. Now take note of this portion here. The portion here we're in. Okay. The liquid here at this portion is in the same level, in the same diameter. Therefore, we will cancel out this portion because they are equal. So the pressure here at the left side is equal to the pressure at the right side. So they are equal. Therefore, we will cancel it out. So what's left for point B now here is the height 0.6 meter from the free surface. Okay, you notice that from the free surface, up to point B. So up to point B, you have there 0.6 meters. Therefore, our pressure here is 0.85 multiplied with 1,000 kilogram. Oops. So 1,000 kilogram per cubic meter for the density of water. And then we have here acceleration of gravity 9.81 meter per second squared, and then the height of 0.6 meter. So pressure at B now is equal to 5 kilopascal. Let's convert that already into 5 kilopascal. So H now is equal to 5 kilonewton per meter squared divided by 9.81 kilonewton per cubic meter, and that is equal to 0.51 meter. So that's the pressure head at A and pressure head at B. So pressure head at A and then pressure head at B. So that's for example number 4. Okay, so that's all for this video.